Hello engineers, welcome to another video on low-level design. In this video, let's look at class diagrams. Okay, I hope you're ready. Let's get started. So let's first look at what's the purpose of class diagrams. Class diagram is used to show the blueprint of the code. It is the entire blueprint of the application, we can say. It contains all the classes, their relationships, their multiplicity, and many other things. We can clearly see what the product is going to be and how the application will shape up when we actually code. So this is the lowest possible level in the low-level design concepts. And beyond this is just the physical code that we need to write, right? So that is the purpose of a class diagram. It will give us the actual visualization of the entire code, right? Now let's look at some notations. So first we have the classes themselves. So class is denoted like this. So this is how a class looks like. First we have a name, which is the name of the class, and then we have the properties of the class, and then we have the methods of the class. So in the properties, we can mention all the attributes that the class will carry, like name, ID, and things like that. And in the methods, we define the behaviors, like what are the setter and getter methods that this class has and things like that, right? So this is a typical structure of a class. Now let's look at the next one, which is the access modifiers. So for every property or method, we can add access modifiers. So there can be three types of modifiers generally: public, private, and protected. So we use one of these modifiers in front of the property or a method to denote whether that particular property or method is public or private. So if it is a public method, any class accessing this class will have access to all the properties and methods. If it is a private method, then only this class can access those properties and methods, and they're not exposed to any other class. And if it is a protected one, it means that if there's an inheritance relationship, the child classes will have access to it, but any external member accessing this class will not have access to it. So that is the point of access modifiers. We have discussed this in our OOPS concepts videos as well. So please watch that if you haven't seen them, right? So let's move on. Then we have the static method. Sometimes we need properties and methods which are not object specific, but they're class specific. For example, you want to know how many objects are created for a particular class. So there is a class and there can be multiple objects that can be created, right? And you want to know the count of those objects. So that is common across all the objects. It's not specific to any particular object, and it is at a class level. So we can create a property or a method at a class level, and we can directly access that method to get the count of all the objects. So that is where we can use static. So to represent some property or a method as static, we simply draw an underscore underneath it like this, and it becomes a static method. So it means that it can be accessed at a class level without using any object, right? Now let's look at some relationships. So first is the association relationship. Let's say we have a class A and we have a class B. If they are somehow communicating with each other, we can use the common association relationship. So if we draw a line like this, it means that A can access B and B can access A. And if we want to show some direction saying A can access B but B cannot access A, we can do it like this. We have a class A and then we have a class B. So we draw a line and put an arrow indicating that A can access B but B cannot access A. So this is a unidirectional association. So if it is a bidirectional one, you need not put any arrow. It automatically means that it is a bidirectional association, right? Now let's look at inheritance. Inheritance is nothing but the parent-child relationship. So let's say we have a parent class and there are multiple child classes like this. So we can draw inheritance relationship like this with a hollow arrow. It means that all the properties of the parent are available in the child class. Again, using access modifiers, we can control which properties are available to the child class, but generally all the properties should be available in the child class, right? So that is the point of inheritance. So we will use this when there is a easier relationship between two classes, parent and child. Now let's look at aggregation. Aggregation and composition or other relationships which are has a type. So one class is part of another class. For example, engine is a part of a vehicle, or keyboard is part of a desktop setup, mouse is part of a desktop setup, and so on, right? So let's say I'm building a desktop setup and I want to create this kind of relationship. Now I know that mouse is part of a desktop setup. Now this type of relationship has a relationship, obviously, because desktop has a mouse. But can mouse live without desktop? Yes, mouse is an independent entity and it can live without the desktop as well. So this type of relationship is called as an aggregation. So there is not a lifecycle dependency. It does not mean that if desktop is destroyed, the mouse is also destroyed, right? Now let's look at composition. Let's say we have a human body and body has so many parts, right? Let's say heart is a part and we have a face. So all these are part of the body. All these are has a relationship with the body class, but this time the heart and face cannot exist without the body. So they are tightly coupled. There is a direct dependency between these classes. So in this case, we can use composition. So if there is a lifecycle dependency between classes, we can use a composition relationship denoted by a full solid diamond, right? So those are the different relationships. Now let's look at multiplicity. Multiplicity is used to denote the count of the relationship. If there are two classes which are having relationship, we can say whether they have a optional relationship or a mandatory relationship, like this. For example, if I'm doing a relationship 0 to 1, it means that the relationship can have 0 to 1. So there can be a minimum of 0 count or there can be a maximum of 1. For example, we use these OTT platforms, right, where we can take subscriptions. I can choose to take a subscription or I can choose to not take a subscription. So there is an optional relationship between user and subscriptions. So in that case, we can use 0 to 1. At the maximum, I can take one subscription per account, right? So in that case, we can use 0 to 1 multiplicity. So how do we denote that? It's like this. So we can denote it like this. So there is a composition relationship because subscription cannot exist without a user, and there can be a maximum of one subscription, or 0. User can choose to not take a subscription. Similarly, we have n multiplicity, which means that there is a defined number of multiplicity. So let's say in my OTT platform, I have mandated that every user should have at least one subscription to watch any kind of video. In that case, I can remove the 0 and directly put 1 there. In that case, it becomes a n multiplicity, which means that every user will have at least one subscription. Similarly, we can imagine the rest of them. If it is 0 or more and we don't know the upper bound, we can use this type of notation. And if it is 1 or more, we can use this type of notation, 1 or more. So it is represented by a star. Similarly, we have m to n, which indicates a range. For example, 0 to 1 was a range, right? We can use such kind of range between 5 to 10 or 10 to 20 or things like that. If there is a relationship that requires a range, then we can use this type of multiplicity. So in any case, the notation will be similar to this. So we use some kind of association between them, some kind of relationship, and then we put the number on top of it to indicate what is the multiplicity, right? So that is the whole point of multiplicity. Now let's talk about interfaces. So how do we define interfaces in class diagram? It is very similar to classes. So the interfaces look like this. It is very similar to classes with an additional notation saying that it is an interface. It means that it will not have an object of its own. It is just a contract which has properties and methods which any class implementing this will have to follow. So if class A is following this interface, it means that it is implementing this interface, and this relationship is denoted like this using a dashed arrow and the keyword implements. So this way we can know that class A is implementing the interface with this name, and it will have all these properties and methods. And within class A, we can show that the methods are being used, right? So that is the point of interfaces. So those are the main notations in a class diagram. Now let's take a look at some examples that I have drawn for you. So in the UML folder, The link will be available in the description below. We have this new file called class diagrams, right? So let's have a look at the examples. So let's start with a simple example for a simple banking system. So let's say we have a customer who's getting authenticated using an authenticator class. So the authenticator class will have three methods: register, login, and logout. And for registration, we are taking email, password, and mobile. And these are the input parameters to this method. And the return type is the user object. So this way we can denote the methods inside a class. So the plus here is indicating that it is a public method, right? So we have a class name, we have the method, and inside the method we have the data types as input parameters and the return type. So that's how we can represent methods. And let's say we have the customer. Let's look at the customer class. We have an ID, email ID, password, mobile number, and registered on, which is a date time. So these are the attributes of the customer. And then we have a constructor here, which is taking in a few parameters, and it will create the object on its own, right? So the authenticator will create a customer using the register method, and it will take care of login and logout as well, right? So I've kept the authenticator as a simple abstraction so that we can focus on other aspects of the class diagram. So we have the customer, and customer has one account, 1 to 2 accounts, because I have given the relationship as savings account or a current account, and a customer can have either a savings account or a current account or both. So that's how we can use the concept of multiplicity to denote the count of relationship between two classes, right? And let's see what is there in account. For an account, we have ID, we have the customer ID, we have the account number, and we have the current balance, and then we have the created on date time. And it is exposing some methods, the get balance, which will give back the current balance, and then user can perform withdrawal for particular amount with some description. User can deposit more amount with some amount and description, and user can transfer funds to another account number using this transfer method, and user can also get some transactions. So what is a transaction? Transaction class is available here. So each transaction will have an ID, an account ID, the amount, the type of transaction, whether it is a credit or a debit, some description, the timestamp of the transaction, and status. Again, there can be more attributes or fewer attributes depending on your system design and the requirements of the use case, but this is a typical banking application, right? So I also added an account manager who will take care of creating the account and closing the account for the customer, right? And then we have the savings account and current account, which are child classes of the account. So these two are has a relationship with the account class, and all these properties will be available in the savings and current account. But I have marked these as private variables, which is slightly incorrect. Let me change them to protected so that our child classes can have access to these variables. So I've changed the access modifiers to protected. So now the child classes can also have access to these variables from the parent class, right? So in this class diagram, we can see multiple things. So firstly, we can see the classes on a whole. Each class has its own properties and methods, and each method has its own set of input parameters and a return type. And then we can see the relationships as well. Here in this case, we have a composition relationship between customer and account, because account cannot exist without a customer. And then we have the multiplicity as well to indicate that a customer can have a minimum of 1 account and maximum of 2 account and things like that, right? So this is an example of a class diagram. Now let's go to a different application, the OTT platform. So let's see what's happening here. So we have the similar structure to before. So we have a customer and we have the authenticator, which is very similar to what we had before in the banking application. And then we have these things here. For an OTT platform, user can take subscription as a choice. So the relationship between customer and subscription is 0 to 1, which means that customer can have no subscription or can have maximum of 1 subscription. And each subscription can have 1 plan. And there can be multiple plans in the application, and each user will subscribe to 1 plan, right? And then after subscribing to our OTT platform, user can access videos. and each video is either a movie or an episode from a web series, and each movie or a web series will have a set of actors in it. Again, we can expand it to bunch of other things. We can also have a director, the music director, and other persons involved, but I try to keep it simple. Now let's take a look at each of these classes in detail. So the authenticator and the customer are the same as before, so I will skip that. Now let's look at subscription. Subscription has an ID, and then it has a plan ID which will come from here, and then we have a customer ID which will come from here. It has a start date, end date, and status. Status is an enum. It is something like whether it is cancelled or in progress or completed or anything like that. And then we have the payment details, which is an object. So if we create another class for payment details, we can attach that here. It will generally have what kind of payment user has used to take this subscription. And it is exposing some methods, get details, which will return some of the attributes of this class. And user can also perform renewal of a subscription. User can also cancel a subscription. So this is a subscription class. Now let's look at subscription plan. So every plan will have an ID, will have a name, will have a price, it will have duration in days, so the amount of time for which the plan will be active, and then maximum devices. So we can restrict the user to log in to certain number of devices, so that is max devices. And then max resolution, we can provide support to allow streaming of videos up to certain resolution for a particular subscription plan. For example, the premium plan can have up to HD, and then the 4K plan can have up to max resolution 4K and things like that, right? So that is the subscription plan. Now let's look at the video. Video has an ID, a title, video title, the location where the video is present. This is the location URL. Maybe it is in some kind of a CDN or in a storage bucket somewhere. And then we have the format of the video, whether it is MP4, MOV or things like that. And then we have the size of the video, the resolution of the video, the duration of the video, which is indicated in length. And then we have the subscription plan ID, whether a subscription plan is required to watch this video. We can also have a free plan to indicate that this can be accessible without a plan, or we can make this a premium video so that user can only watch this if there is a premium subscription attached to the user. And then we have other metadata like release date and so on. So I've given a simple stream method to return a buffer stream to access this video. But again, this can involve a bunch of things depending on the streaming platform. There can be multiple bit rates, different resolution types for different device types and so on. And then we have a common get details method, which will return some of the details here. Now let's look at movie, which is a child class of the video. So movie is also a video, which it will have all the properties of a video. And then we have additional details like a cast, genre, and a rating. So a cast is a array of actors, and each actor has a name and a photo. So there can be a multiple relationship between actor and the movie. So at least one actor is required in a movie. So I have given the multiplicity as 1 to many. Similarly, an episode is also a video which will be part of a series. So the series is having 1 to many relationship with the episode class, and series has ID, title, genre, rating, and actors, and episode has the series ID, the season number, episode number, and so on. Again, there can be more details or fewer details depending on the requirement, but we are practicing class diagrams, so I try to keep it simple, right? So let's see the notations that are part of this diagram. Firstly, we have the classes, and then we have the relationships, has a relationship, which is a composition, and then we can see multiplicity. We can also see inheritance relationship in this along with multiplicity, right? So this is a simple OTT system. Now let's look at a slightly complex system, the AuthProvider. Now let me walk you through this, then I will explain what this is doing. So first we have an auth factory, which will create a strategy for authenticating someone. So this is an authentication provider system. So there is a auth factory class, which will have one method called create strategy. It will create a strategy based on this interface. this interface is an auth strategy interface. It has only one method called authenticate. And we are supporting two strategies, email strategy and OTP strategy. If there are more strategies, we can add more strategies to this system as well. Maybe like a OAuth system for social login with Google or Apple ID or things like that. And then once this strategy is created, we have the authentication context class, which has a constructor called authentication context, which will take in a auth strategy. Auth strategy is coming from the auth factory. And then we are exposing the login method, using which any user can log into the system by providing the respective credentials. And within this login method, we will call the authenticate method of the interface, and it will invoke the respective authenticate method depending on the strategy being used. And once the user is logged in successfully, we have the user object that will come out, which simply has name, email ID, password, mobile number, and so on. And user can do set password, set name, and other things depending on the application, right? So this is a simplified version of an auth provider. So there is a common interface for auth strategy, and multiple classes can implement the same strategy by implementing the authenticate method. So in this way, we can keep the system flexible because we can keep on adding the different strategies depending on the use case and the new developments in technology. And we have the common auth factory and authentication context, which are separated in their concerns. The auth factory is only responsible for creating a strategy, and authentication context is responsible for using that strategy and providing login. So if there is any other checks that are required for login, we can do so here. And if there is any change required in creating an object, we can do so from here. So I know we have not discussed the design patterns and principles in detail, but here in this case, we can clearly see the separation of concerns, which is the single responsibility principle. Auth factory is taking care of creation of object, context is taking care of login, and we have separate email strategy, OTP strategy, which are taking care of authentication. And there are a couple of design patterns used here. We have the factory pattern, and then we have the strategy pattern clearly shown in this. So if you're not understanding this example as of now, there is nothing to worry. We will cover this in the future videos where we will discuss the different design patterns, right? Now for the practice question, it will be really nice if you can continue building an e-commerce website. You already must be having the use case diagram and the sequence diagram from the previous practice sessions. So continue on that and build a class diagram and share the link in the comment below, and I will try to review it and provide my comments and feedback to you as well, right? So that's all I had for this video, guys. We covered pretty much everything that we need to know about class diagrams. If you still have any other questions, definitely ask me. Don't forget to leave a like if you found this video helpful. Do comment if you have any questions. Don't forget to subscribe if you haven't done already. Share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.